welcome everyone. We should be got 19 people that have joined us so far. So I'm going to go ahead and give it just a second to get more people in to the webinar, and then we'll get started. I don't know why the chat function isn't up. You can hear me, either add to the chat or to the Q&A that you can hear me. That would be great. Yep, good. We're good to go. Okay, well, let's go ahead and get started. It is 12 o'clock exactly. My name is Stephanie Aden, and I'm Executive Director of AIA Spokane. Welcome to the first continuing education remote, live, and local that AIA Spokane hosts. We hope to do these once a month. It's our goal, so keep checking back on our website and emails and join us each and every month. Today, we have a presentation being presented by Swinerton, and it's called Mass Timber Efficiencies. They're actually going to do a second one on February 22nd February 25th, and are very interested in what you'd like the topics to be. So through the Q&A or the chat, I'm looking, maybe the chat function is not functioning right now. If you could just, as you are thinking about it during the webinar, go ahead and just pose some ideas of what you'd like them to cover for the next series that they will do in February. So with that, I want to go ahead and introduce our presenters. From Swinerton Mass Timber, we have Sam Dick, who's Business Development Manager, and we also have Erica Spiritos, who's the Pre-Construction Manager. They will be moderating their presentations. They've got it formatted into 4 separate case studies, and we'll ask for your questions through the Q&A and answer those after each little mini chapter. So go ahead and enter your questions in the Q&A, and we'll make sure and get those answered. So you guys know why you're here. I'm not going to go over the program description, but you will get credit for this course. So I do want to go through the learning objectives. At the end of this, you as participants will gain an understanding of the design, procurement, detailing, fabrication, and installation of mass timber for high-rise residential construction. You'll understand the building code and safety opportunities for building heights and area limits based on construction type for mass timber. And you'll utilize the latest technologies and methods of testing for determining the fire resistance of high-rise in residential for mass timbers. And you will review structural design in high-rise residential utilizing mass timber and my little screen is popped up against that, so you can read the rest of that. So go ahead and email me at office@aiaspokane.org if you're an AIA member and would like to receive credit for this course. And with that, I'm going to go ahead and turn it over to Sam and Erica. Thanks so much for joining us, and I'm going to go ahead and let you take over.
Awesome. Well, thank you so much, Stephanie, for hosting us here today. This is super exciting, and good afternoon, everyone who's attending the call. My name is Sam Dickey, and as Stephanie mentioned, I'm Business Development for Swinerton Mass Timber. Today, we're going to tell you a great presentation about ways to find efficiencies on designing and building a mass timber building. We've got a great presentation for you, but before we get into that, I'll let Erica introduce herself, and then I'll share my screen.
Hi, everyone. Thanks, Sam. And thank you, Stephanie, for having us here today. Excited to be with you all virtually in Spokane from Portland. I am the pre-construction manager for our mass timber group. I've been working in the mass timber space for about 6 or so years now, first with a developer in New York, and then with a manufacturer out of British Columbia, and now with Swinerton. I have looked at mass timber from a number of different angles and can provide some insight accordingly. Really excited to talk to you today about a number of projects we've worked on and some specific considerations about mass timber as Sam described. So please feel free to chime in with questions in the Q&A, and we will definitely make sure to tend to those. We want to make sure you're getting information that is relevant and interesting to you. So
Yeah, so just to echo Erica's point, we've got 4 specific sections that we're going to talk to you today. And after each section, we'll just take a second to answer questions. So feel free to populate those in the chat or in the Q&A. And then also, as Stephanie mentioned, we're going to be doing a presentation for y'all in February, and would love to get your input on what you guys are interested in learning more about after you hear our presentation today. If there's a topic that you'd like us to dig deeper into, we'd love to explore that as well. So I'm going to go ahead and share my screen here, and we'll get started with our presentation. All right. So we should be good to go. So really what we like to do before we jump into the meat and potatoes of the presentation is tell you a little bit about who Swinerton is as a 132-year-old general contracting firm, and then also who Swinerton Mass Timber is more specifically, and our specific business unit that Erica and I are a part of. So really where we like to start is our mission statement. I think this fuels everyone on our team, and really it's to accelerate the mainstream adoption of mass timber in the commercial construction market. And as we go in a little bit further into the presentation, we'll show you guys who all's on our team, but this mission statement is what drives each and every one of us to be a part of this mass timber movement and this mass timber community. This is a great little description of all the services that we provide, from design, procurement, detailing, and fabrication, to the actual planning and execution. As you can see in this chart here of who all is on our team, which I love because it shows all of our faces and the different levels of the process that we work in, we have a really diverse group of folks. And some people think, oh, you know, your mass timber team's, you know, 3 people. No, we have a full team devoted to mass timber development. We've got about 30 folks, and ranging from construction backgrounds, engineering backgrounds. Erica had mentioned her background working for a supplier. I like to tell folks I was a history major in college, and I worked in the public sector. So, you know, this attracts people from all different walks of life, but all different skills and strengths. We have architects on our team. We'll talk a little bit today about the fabrication component. On January 1st, Swinerton launched a new company called Timber Lab, which is actually just dedicated to being a supply partner and focusing on the fabrication component and the timber engineering selection. So, but our mass timber team ranges as a fully vertically integrated team from cradle to grave, as they say, all the way through the development process here. And this is a good look at where we interface with that process. We've completed about 14 mass timber projects. This map here shows a lot of our experience on the West Coast. However, we are branching out. We work for other general contractors, about 40% in markets specifically where Swinerton doesn't have a presence, including a project we're going to talk a little bit with you about today called Ascent in Milwaukee, Wisconsin. That's just getting under construction, and timber starting to go up this spring. But we've had experience all over the Pacific Northwest, all along the I-5 corridor, and then out throughout the rest of the country as well. And then specifically for today's presentation, we're going to focus on 4 main chapters. So procurement implications for design, thinking about capabilities of manufacturers and sourcing for those concerns and challenges. BIM for fabrication, diving into the specifics of actually designing a project in a 3D model before actually getting out to the construction site. Understanding the ins and outs of the code. We'll give you an update on the 2021 Ibc codes, as well as talk about a specific project that we used that used a variance in the heavy timber ordinance, and then specifically mass timber coordination between concrete and steel. And each one of these topics, we like to say, you know, they could each of them be their own PowerPoint presentation that we could spend a whole hour on. So we're really going to hit this at a high level and try to dig in a little bit deeper. And if you guys are interested in learning more, we'd love to set up a specific presentation with each of you guys individually, or maybe bring some of these topics back for further discussion at future AIA meetings. All right, with that being said, I'm going to kick it off here with our first specific topic, which is procurement implications for design. And real quick, I'm going to do a brief introduction of the project that we're going to be talking about, and then kick it over to Erica to talk about some of the specifics the challenges and opportunities that we faced for this specific project. So the project that we're going to be talking about is the Oregon State University's Cascade campus. It was about a 50,000 square foot gross mass timber structure. It was a type 3 building, and it's in Bend, Oregon. It was predominantly classroom, lab, and academic classroom space down there. All right. Erica, you want to talk a little bit about supply for the project?
Yeah. So I think the first thing to mention for this project is that we had the luxury of utilizing type 3B construction, and that really benefits us for our mass timber design because it allows us to utilize a 3-ply Clt panel. And as many of you might know, the driving factor in the cost of a mass timber structure is the total volume of wood fiber in the building, and the largest amount of wood is in that CLT deck. So as much as we can, we want to seize opportunities to reduce the thickness of the CLT panel. And whenever we don't have any fire rating requirements for our structure, as in the case of this Oregon State project, we look to using a thin 3-ply panel. So that 3-ply panel generally spans 10 to 12 feet, depending on the live loading criteria and requirements in the building. In this specific building, we've got 10-foot spacing between glulam frames, so that CLT panel is spanning 10 feet. And we found that that was really amenable to a number of different supply options and reduces waste pretty much with many of those suppliers or manufacturing partners. So those are some of the initial considerations. And then the other priority of Oregon State University was to utilize regionally sourced material. So we look to our supply partners in the Pacific Northwest. Many of them are shown on this map that we've got here on the screen. For this project, we ended up working with Vaughan Timbers out of Colville, Washington, your neighbor in Spokane. And they provided CLT panels for the project. And then we sourced glulam beams and columns from Zippo laminators out of Eugene, Oregon. They're a commodity glulam manufacturer, so they don't have 3D modeling capability or CNC capability. And at that time, we didn't have our fabrication shop up and running. So actually, Vaughan partnered with them, and we sent all the Zippo glulam products up to Colville for fabrication at Russ Vaughan's facility up there. And then he shipped it back down to us, fully fabricated with hardware installed, ready to go. So we had a number of really awesome supply partners on this project, Zippo and Vaughan being two of them. We sourced steel connectors from a regional steel fabricator, and then fasteners from, those typically come from Europe. So this is a really good kind of big picture snapshot of the suppliers that exist in that mass timber space and the varying levels of capability and services that each offers. I think it's important to kind of lay them out in this format because it gives you a sense of where there are gaps and where we might be able to complement one company's capabilities with our own in-house capabilities to provide a complete package. So for example, in this particular project, I said we worked with Vaughan. They offer CNC fabrication, and they offer PRG 320 certified CLT. At the time, they weren't making glulam beams in the sizes that we needed. So we said, okay, we'll work with Zippo laminators a little bit further down down on this list. We'll buy glulam from them, and we'll kind of put together these pieces that otherwise wouldn't be able to provide the whole project on their own, and we'll form a complete package, the best value for the owner by putting together these, different manufacturers and complementing with our in-house capabilities. So for this project, we did all the in-house 3D modeling and then worked with these supply partners to put the package together. We talked about, or the topic of this case study is design and procurement implications of design. And so one thing to note is that when we design or when we set our grid spacing, our glulam frame layout, we are inevitably making a decision that will benefit one manufacturer over another. And we might not know that we're doing that, but it's good to be aware of the implication of that decision. So for example, we might be looking at 15-foot spans between frames, in which case vendor B looks to be the most efficient from both a manufacturing perspective and an installation perspective. There's 2% waste in their billet utilization when they press that panel. That's really great. And then from an installation standpoint, we're always thinking about the number of crane picks. So how many panels do we have to place? And we're hoping to place as few panels as possible. So vendor B works out pretty well. Vendor C is challenging a bit because of the narrow width of that panel. So it increases the number of panels because of that width limitation. Whereas with a 13'4" grid layout, we have a different vendor who all of a sudden rises to the top. Vendor A becomes more competitive. And so if we want to work with a specific manufacturer, or we have a feeling that the owner or the architect prefers a certain wood species over another, they would rather have European spruce instead of Douglas fir, for example, then we want to notify the design team about the implications so that we can get to the most efficient structure. Often we don't have the luxury of designing based on this, but it is important to be aware of the procurement implications as we start that even schematic design decision-making process. So here's a quick snapshot of the various manufacturers that exist in this space. It's not complete. I think there are a couple that are missing, but it just gives you a sense of the modularity of the different panels that are on the market and the implications of buying one over another. So for example, it looks like the structure craft panel is really large, the Katera panel is really large, and so those panels present an installation advantage. Whereas a panel that's smaller requires more crane picks, more spline, more fasteners, more seam tape, just more accessories in order to install that deck. So sometimes that becomes a determining factor in who we work with, but it's always a consideration usually in the schematic design and design development stage of a project when we're making those design decisions that affect our procurement strategy. So here are three structural systems that we looked at for the OSU project. On the far left, you see 15-foot spacing between frames. In the middle, you see 10-foot spacing. I think that's 10-foot spacing between frames. And on the far right, you see a steel system. We also considered a fourth option, which was a hybrid steel frame with CLT deck. And ultimately, we went with this 10-foot spacing, which allowed us to utilize the thinnest CLT panel on the project, reduce our total demand for wood fiber in the structure, and get to the lowest cost for the mass timber structure. Because even though the university was really excited about mass timber, ultimately the project needed to be cost competitive with the steel option that they were benchmarking against. There were some other implications to our structural system having to do with embodied carbon. Typically, we're looking at the total volume of wood fiber and then making a calculation about the amount of carbon that's stored in that wood structure. But as I said, really the first concern or consideration is about cost. And we found that the Three-Ply system with 10-foot spacing between the glulam frames allowed for a 25 to 30% reduction in the structural material requirements, which offered significant cost savings. And this scheme worked well with the programmatic layout and needs of the project, and so it made sense to go with this system over that 5-ply system, which would have been more than we needed for fire, for example, but would have been a kind of a decision that an owner might have chosen to make to spend that money if that 13'4" spacing was really important for another reason. Let's see this. So I think what I want to talk about here is just the installation efficiency. The The 8x40 system that you see up top lends itself to a more efficient installation. You've got 67 panels per floor deck, roughly, whereas this 4 foot by 60 foot CLT panel system increases the amount of picks significantly to 100 per level. It may be that that's the make or break kind of factor that sets your procurement strategy. In this case, we did decide to go with the 4 foot by 60 foot panels, and we figured out a way to bundle pick the panels so that we were picking like panels at the same time from the truck, setting them on the deck, and then shagging them out on the deck to reduce our overall crane demand. So a little bit of kind of innovative, creative thinking there to figure out ways to make this system work, because it was most advantageous from a cost perspective. Here's what that bundling looked like. So color coded, as you can see, we've got picks that are single picks that are bundles, and then yeah, I think a number of different types of crane picks based on that 4 foot by 60 panel. So yeah, good visual of that. And here's what that looks like under construction. We just completed the installation of this structure at the end of last year. But as you see, 10 foot spacing between the frames and 4 foot by 60 foot typical CLT panel.
So before we move on to the next project and the next lesson, did we have any questions come in?
I didn't see any questions, but maybe we'll give it a minute.
Cool. All right. Well, if any questions do come in, feel free to type those in the Q&A there in the chat, and we'll stop after our next project and go over those as well. And then we should have a little bit of time at the end of the presentation as well. So
can these be used for exposed conditions? Mark asks. Oh. We can definitely utilize glulam in an exposed and exterior application. We'd want to be thoughtful about coatings or wood species selection to reduce weathering over time and to protect that wood from degradation from the elements. So definitely doable, and there are a number of ways to protect the timber. CLT I've seen used as an overhang, but we don't otherwise see exposed CLT panels. And that's really just because, well, the CLT PRG 320 certification for the manufacturing standard for this product calls for use only in interior applications. So it's kind of a code limitation at this point. I imagine in the future we might end up using CLT in some kind of exterior application. There are considerations around just checking of the material. So there are challenges. We always want to be sure to protect end grain because that's where moisture enters and leaves the timber. So we do that with typically like tape, wax edge sealer, membranes, things like that. What does the cross section of the panel look like? Oh, great question. Imagine lumber laid crosswise in alternating layers. So if my fingers were 2x6s, you'd have, out of the page in one direction, you see the 2x6, and then in the other direction, you see the side of that stick of lumber, and then the next layer you see the end grain, and then the next layer you see the side of that piece of lumber. I think that's all the questions we've got so far.
Awesome. I think we might have some pictures of CLT panels later in the presentation, so we'll keep an eye out for those and point them out if we do.
Yeah. One more thing to note here from this photo, our lateral system on this project was concrete shear walls. We do projects with concrete shear wall lateral systems, with steel buckling restrained brace frame lateral systems. In other parts of the country, we see CLT shear wall systems. And then if we were to utilize like a hybrid light frame and CLT structure, we might have plywood shear walls. So a number of different lateral systems are possible with a mass timber structure. And in this case, the concrete shear walls made the most sense.
All right, so in the second lesson, we're going to talk specifically about BIM for fabrication. And we're going to talk about this building information modeling system specifically on a project that we're doing down in San Francisco area at the University of California, Santa Cruz, Kresge College. We're actually doing a number of different projects for the university down there, including academic building and then 3 residence halls. Today, we're just going to talk about one of those residence halls, which is totaling about 60,000 square feet for all 3 of them. And it's sort of a podium construction that Erica is going to talk specifically about. But one of the interesting things about this project is that it uses a CLT flooring system, but then a prefabricated stick walls for the rest of the project. This is a great map to kind of show that campus construction there. One of the interesting things about, if y'all have ever been down to Santa Cruz, you know that a lot of it's a forest. So there's some specific challenges and opportunities associated with building in the tight constraints that allowed mass timber to really shine as an application material for this.
So as you can see in this diagram, we've got a type 5A 1-hour rated structure over a concrete podium. You might ask why we might choose to use CLT decks instead of a typical I-joist assembly. The real value is in the aesthetic of having an exposed CLT ceiling, and that was the architectural intent for this project. There are some other benefits associated with the CLT floor system, reduced thickness of that floor assembly, leading to overall reduction in the amount of skin on the exterior, the building height while maintaining the floor to ceiling height. But the schedule advantage of utilizing a prefabricated component in the construction of this building, a large prefabricated component. But there are also challenges. So when we usually build type 5 structures, stick-built walls with I-joists, we're not modeling them necessarily. Maybe a contractor is using 3D modeling for coordination or class detection, but certainly not for fabrication. And so the level of detail that's required and the level of effort that's required in that 3D modeling process makes it a whole different ballgame, because we're trying to coordinate penetrations precise to the 16th of an inch through the CLT deck and making sure that there's no issue in the routing of mechanical, electrical, plumbing, fire sprinkler services through the walls, vertically and then horizontally across that deck. So here's what that process looks like. It's kind of a 2-step process. The first step involves getting everyone in agreement on the geometry of the building precise to that, within that timber tolerance of about 16th of an inch. And so that means reconciling architectural, structural, mechanical, all trades, and figuring out exactly where the edge of deck is, for example, and then exactly the sizes of all penetrations and exactly where they'll be located in that deck. I would call it even a 4th phase of design. It goes beyond what we usually develop in the construction documents process, and this phase typically takes place in parallel to the construction documents phase. So it's almost like you're doing construction administration while you're doing construction documents, if that makes sense. Really answering a lot of those questions about precise locations and sizing. And that's what enables the prefabrication of the timber structure, and then enables speedy construction, not just in the timber erection, but with all the follow-on work that happens in the installation of fire sprinkler pipe and plumbing and electrical hardware and things like that. So it's a lot of work up front to coordinate those trades, but it's definitely worthwhile. And we find that there are really significant benefits in terms of quality of work, schedule enhancement, safety of work on site, and then just cost reduction because of that reduced construction timeline. So we're always beginning with the 2D documents, the latest set of plans. Hopefully they're permitted or they're getting permitted, because we don't want to fabricate anything at risk of, major design changes pending, review from the building department. But we're working with the 2D documents because that's what we're contractually tied to. So even if the architect or the engineer has their own structural or architectural model, we look at those as a reference for sure. But we're building our own model off of the 2D plans. And then from there, we're building 3D models that take into account the structure and then any material that the structure might interface with. So that might be concrete slab, it might be concrete cores, it might be steel brace frames. In this case, we're looking at all of the fire sprinkler pipe, we're looking at ducts, we're looking at, plumbing, and thinking about how that all routes through prefabricated stud walls and then penetrates up through CLT floor decks. Making sure that there's no clash with the hold downs at the base of the wall, or making sure that the walls don't cover up penetrations, for example. And so that, that process, when people ask like, what's the lead time associated with mass timber? Like so much of that is related to this process. Like how long does it take to figure out exactly what we need to fabricate, especially for jobs of like less than 100,000 square feet. Usually the bulk of that lead time is associated with this shop drawing or detailing process where we are building the structure, where we're constructing the whole building in virtual setting, rather than like the bulk of that time being consumed in the manufacturing facility. So it's definitely a full gas effort, weekly coordination meetings, and then RFIs to memorialize decisions and any changes that are made to the design as we move forward. So then after we do that 3D kind of geometry coordination, we move into timber detailing. And that's where we get really specific about the timber structure, how all the pieces fit together. We look at material tolerances. We look at movement that we expect or anticipate with differences in behavior between the timber and another structural material that it might touch. We look at the connection detail and tolerances with any steel, fabricated, welded steel assembly that might be integrated into that connection. And then we take all of that information and we use it to fabricate both the glulam beams and the steel connections. We send all that information to the glulam fabricator and to the steel fabricator. Here's what that looks like, translating two-dimensional design intent into three-dimensional kind of almost reality. This is what we ultimately fabricate. I think looks like there was a little bit of design change on that detail, but we're thinking about how that detail works for fabrication. Can we make those cuts with the CNC machine that we are using on this project? And then how does it fit together in the field? Are we going to have any issues with tolerances or, just pieces fitting together? And always looking at minimum bearing for glulam on steel base plates or bearing plates, for example, things like that. Thinking about steel beam sway if we've got hybrid systems. So lots of considerations there, but this virtual construction process really pays off when we get to the construction site.
And Erica, just one thing I wanted to add to that is, one of the advantages of having this service in-house and being done at our factory in North Portland is that, one of our timber detailers, Ben or Lauren or Chad, whoever's working on this particular project, is only about 100 feet away from the machine that's going to be cutting this and from the operators that are going to be operating the machine. So there's a true integration between this work that allows for that constant communication, which really helps when it comes to coordinating such a massive project like this.
Totally. So we got one question. How much flexibility, Robert asks, how much flexibility does the panel have to accommodate surprise penetrations? There is definitely flexibility to accommodate surprise penetrations. The wood can be pretty easily modified on site. I mean, it's a matter of coring through, you know, a 4-inch or a 7-inch thick piece of timber, and there are tools to do that. The quality of that penetration is probably going to be slightly inferior to what you could achieve with a robotic cutting machine, but it's definitely possible, and you don't have to worry about, you know, accidentally hitting rebar or anything like that. Penetrations of a certain size, probably greater than, I don't know, 5 inches in diameter, probably have to be approved by the structural engineer of record, because they might compromise the integrity of the panel, and then you'd need additional structural support. But for the most part, it is possible to make modifications, and sometimes we have to do that.
Awesome. Any other questions that came in?
That's all I saw.
Cool. Well, keep them coming if you guys think of them. They're great questions so far. This next section, we're just going to talk about the new 2021 IBC code changes, and then also our experience of working with AJCs in actually permitting going to be the tallest mass timber project, I believe, in the world, if not North America, 25-story timber tower in Milwaukee, Wisconsin, high-rise residential project. But we're going to spend a little bit of time just giving an overview of the updated code, probably more relevant to what you guys are working on in Spokane, and then jump a little bit into that project.
So as I mentioned earlier, there are cost implications to construction type selection. And sometimes we think we are destined for a specific construction type, and other times we realize that we have options. So some of those options come into play when we're considering a type 3 building. Could it be 3B? Could it be a non-rated structure? Or does it have to be a 3A 1-hour rated structure? Additionally, we have options in looking at type 4 heavy timber. Fire rating for type 4 heavy timber buildings is calculated based on prescriptive sizes for members rather than based on a calculation for char. So the methodology actually leads to different sizes of the glulam beams and columns, for example, or different thicknesses in the CLT panels that are required to achieve that rating, that 1-hour rating in the case of the type 3A building, or that kind of heavy timber fire rating, which is assumed 1 hour, but just calculated really differently. So as I mentioned, the CLT thickness is the #1 driver for cost. The baseline 0-hour rating might allow you to use would allow you to use a 3-ply CLT panel for, you know, certain span. And then a 1-hour rated structure might add $5 to $10 per square foot. And then a 2-hour rated structure might even add beyond that $12 a square foot for that additional wood fiber. So as much as possible, we're trying to make smart decisions regarding construction type, because there is a ripple effect in that cost. And that cost comes not just in the form of wood fiber, although that's the biggest kind of cost driver, but it's in the concealing of steel connections for fire rated structures, and in fire tape, fire caulking that's required to protect joints. So there's lots of kind of small ripples to this decision that we want to be aware of. Some of you may be aware that the 2021 IBC includes provisions and, in fact, new construction types for tall wood buildings, which is super exciting. There hasn't been a new construction type in many, many decades. So we are now able to build type 4 A, B, and C buildings up to 270, 180, and 85 feet respectively. Those are equivalent to other structures that, type 1A and 1B structures, for example. So the type 4A structure has the same fire and life safety requirements as a type 1A building, 3-hour rated vertical structure and 2-hour rated horizontal structure. Type 4C is a 2-hour rated structure, fully exposed timber. Type 4A requires full encapsulation of that timber structure. And then type 4B is kind of a hybrid where you can expose 20% of the timber ceiling surface area or 40% of the timber wall surface area, that's columns too, or a ratio of those two calculations. So definitely some limitations there, but amazing that we have an opportunity now to use timber in buildings taller than 85 feet and taller than 6 stories, because up until now, that was the limitation with type 3A and type 4 heavy timber buildings.
And interestingly enough, we're going to talk just briefly about a project that I mentioned we're doing in Milwaukee that starts, broke ground last summer, but timber starts to fly on it this spring. It's a 400,000 square foot, 25-story high rise with 6 stories of parking as concrete, acting as podium, and then 19 stories of timber. And we're going to talk about the pathway that we use to get this project permitted. When we started this process, the new IBC building codes hadn't been officially ratified. And so we had to work specifically with the jurisdiction in Milwaukee. And Erica, I believe, didn't one of the fire marshals in Milwaukee sit on the code change committee, or at least was extremely familiar with the code change process? I remember them being very involved. And so it involved a lot of testing. We had to work with our suppliers to get specific testing done for members to prove certain things, and then lots of late night conversations with the folks there in Milwaukee to prove some of the things that we wanted to accomplish.
So as Milwaukee has not yet adopted the 2021 Tallwood building code, we had a couple of options for permitting this mass timber structure. The team looked at type 1A with variances for material, and type 4 heavy timber with variances for height and number of stories and gross square footage. Ultimately, the building department was most comfortable permitting the building as type 4 heavy timber. It's timber, let it be a timber building. But we were required to meet the type 1 fire rating requirements. So the structure is 3 hours. The vertical structure has a 3-hour rating. All those glulam columns are designed to resist a 3-hour fire, and the horizontal elements, beams and panels are designed to resist a 2-hour fire. Some considerations and challenges arise when we work with type 4 heavy timber buildings. Mostly the type 4 heavy timber structures we know of are office buildings, and you don't really have a lot of concealed spaces. But when you're doing a residential building with a lot of concealed spaces and bathrooms and kitchens and corridors, we have to figure out how to protect those concealed spaces. And there are a number of different options. And ultimately, what we decided to do was, I think we decided to do option 3, but oh my God, now I'm getting a little confused.
I think we decided to cover with Jim.
I'm looking at all of them right now and I'm like, they all look familiar. Yeah, so really it's a question of cost, and just, knowing that to create that, to protect that concealed space, there either needs to be fire sprinkler insulation or gypsum wallboard applied to the underside of that CLT ceiling. So the fire rating requirements for the building were as I described, and we used this CHAR calculation methodology to validate the fire rating for the beams. To validate the fire rating for the columns and the CLT panel, we actually tested those products. So that was number 3, what you see here. We actually performed testing, and I think, Sam, that might be your next slide. Never before had there been fire testing to validate char rate for a 3-hour fire for a glulam column. And so we conducted this testing at the Forest Products Laboratory in Madison, Wisconsin, and found that the char rating that was evident after testing was even better performing than what we had calculated. And so this was really positive and exciting news, and made the fire marshals in Milwaukee feel comfortable moving forward to expose roughly 50% of the glulam columns in this structure. And we made decisions early on to strategically encapsulate some of the glulam beams and columns. No need. So when you expose a timber column in a fire rated structure, you have to upsize the member, and it's called sacrificial material. But basically the idea is that the timber could burn for 1 or 2, or in this case 3 hours, and you would still have enough cross-sectional area to withstand the weight of whatever load was being applied to that element. And in this case, the upsizing was significant for a 3-hour rated element. It's about 4.5 inches or so per exposed side. So for example, why expose a timber column in a closet? Better to have more closet space. Downsize that element and then cover it up with gypsum wallboard and call it a day. So we thought about where exposing the timber would add real value to the tenant, to the occupant, and where it wouldn't add too much value, and then figured out which elements to expose and conceal that way. Here's some photos of our CLT panel testing. You might be familiar with many 2-hour fire tests that manufacturers have for their 5-ply panels. We chose to do testing because we were trying to achieve spans that were slightly longer than ones that the other 2-hour fire tests were able to meet. So this was a project-specific fire test to validate 2-hour fire rating for roughly 17-foot spans.
All
okay.
Right. Got questions?
Yeah. James MacArthur asked, no fire protection, so fully sprinklered. Yes, the building will be fully sprinklered. And the fire protection is in the form of upsizing of the timber members to provide that sacrificial char, and in encapsulation of some of the timber components with usually 2 layers of gypsum wallboard sheetrock. And then another question, I noticed a CLT member at Katera in Spokane that resembled a double T concrete member. Could it be? Yes, you're right. You saw that. That is what we would call a ribbed CLT panel. So, imagine like a 10-foot wide by 60-foot long panel with 2 glulam beams running underneath the panel, launched lengthwise down the whole panel. That system is utilized in applications where we've got longer spans. It just increases the spanning capability of the CLT panel. It does increase the amount of wood fiber in the system, so I'm not sure it's necessarily the most structurally efficient, but there are definitely applications. And in residential, it actually could work quite well with just distribution of services through the units, from the corridor to the units. So yeah, I'm really interested. I'm curious about the system. We haven't built one like that though. Cody, are there special structural connections that accommodate for a 3-hour fire event? That is a great question. And to my knowledge, no, there are not. But that doesn't mean that there couldn't be. Right now, the code only requires 2-hour ratings for the connections. And so that just means that any steel that's in the connection has to be protected for 2 hours so that the fire wouldn't reach the steel in that 2-hour fire event. Because actually the steel becomes the weakest link at that point, just melts and loses its strength much more rapidly than the timber does. I think to accommodate a 3-hour fire, you would just increase that char around the steel another 1.5 inches or so. But it's a connection that you would want to have tested. Yeah. Great
Erica,
question.
Do you want to briefly mention the testing that we've done for some of our connection detailing and how we've done that in-house for R&D?
Yeah, so we actually noticed kind of a lack of 2-hour rated connections on the market. There had only been testing for one connection design that was going to be used on a project called Framework that was planning to be built in Portland, didn't get built yet. And so we decided to design our own 2-hour connection that was, we felt, a little bit more cost effective. And we did that fire testing over the winter in Texas, San Antonio. So now we have a 2-hour fire rated connection for some of these projects, which is really helpful. Daniel says, how will the imminent implementation of the 2018 version of the Washington State Energy Code, how is it going to affect the mass timber construction? Great question. I wish I knew more about energy code. I think that, you know, the requirements have, I'm not even going to try. I don't know the answer. I will say that the new structural code changes do also impact the viability of mass timber. Mostly seismic loads are being increased per that new code update, and so lateral force resisting systems are getting larger. And so the lightweight nature of a mass timber structure actually works to our benefit because we're not having to upsize the lateral system as much as you would need to in a concrete building, for example. But when it comes to energy code, I really can't speak to that. So I'm gonna have to learn something. Sorry, Daniel. No other questions. I'll just quickly wrap up with this last case study in the next couple minutes, and then we can wrap up.
Perfect. All right. Let's talk about coordination between steel and concrete.
Okay, so I just wanted to show a number of hybrid structures that might just get the wheels turning about some of the considerations when timber interacts with other structural materials like steel or concrete. So in this case, you're looking at a timber connector bridge between two adjacent structures utilizing steel supports. So in this case, you've got steel posts and then a steel angle that's supporting the Clt panels. And those Clt panels are running, the major strength axis of that panel is across the width of that connector. So I think, you know, some of the considerations here are just around minimum bearing, making sure that the Clt panel has enough, you know, steel to bear on, and making sure that that is designed with consideration for steel beam sway and the tolerances that steel is both manufactured to and how it behaves in, you know, hot weather and things like that. Interestingly, steel and wood both move, but they move in different conditions. You know, steel moves when it's hot and wood moves when it's wet. So just want to think about the interface between those two materials and design details that are forgiving of those kinds of situations. Next slide. And maybe Sam will just kind of run through these quickly. Timber stair system here. These are feature stairs at the University of Oregon. We built 12 of these stairs. Some of them are even spiral staircases. There you go. So lots of opportunity there. Here's a hybrid structure, CLT decks with steel frames. Similar considerations here around manufacturing tolerances. Also have to take into account trade sequencing and just coordination of the, you know, geometry of this structure, it's really helpful if one group could detail the entire structure for fabrication rather than trying to marry a timber fabrication level model to a steel fabrication level model by another modeling group. Aerial shot of the same building. Sometimes these buildings call for double height steel columns, and so we want to be thoughtful about like erection aids that can get in the way of placing Clt panels. Lots of little things like that can trip us up in the field. And then this is another steel hybrid project, which really was challenging for us. So we'll just end on a challenging note. But this one was challenging because the design was not done in consideration of construction sequencing. So the way the details worked actually required setting a steel post, setting a CLT wall, setting a steel post, setting a CLT wall, rather than setting all the steel and then all the CLT behind it. And so that kind of coordination of the crane and the crews was just challenging.
This is actually an interactive, you can see.
Oh, cool.
With the one panel and then the steel and then another panel and then the steel and then the last panel. Yeah.
Oh my God.
So whoever put this together did a great job of, and their PowerPoint skills are very impressive.
Yeah, so actually this just brings me to one other point, which is that project delivery method really matters for mass timber. This project was a public job, design, bid, build. We had no insight into the design process or no opportunity to provide feedback. And so we find that mass timber projects tend to be really most successful when there can be construction feedback or constructability feedback incorporated into that design process. So we typically advocate for CMGC or design build, or at least design assist approaches to delivering mass timber buildings. All right, that's it. 1256, we did pretty well, Sam.
Cool, yeah, hey, that's pretty good. Let's see.
Well, thank you all. Thank you all for spending the hour with us. Glad to take any questions that might pop up in the last couple of minutes.
And please feel free to share if there were anything that struck your fancy that you'd like to learn more about in terms of design capabilities, net zero. You know, there's a lot that we didn't dive into today that we would love to come back and talk to you guys in February about. Oh, and Stephanie, I think you might be on mute.
I haven't seen anything in the chat session, so if we don't enter it there, please feel free to email me and I'll get your comments of any programming ideas you'd like to have these guys cover in a month. So please, I encourage you to do that. Oh, it looks like we do have a couple more questions.
Yeah, Robert says, would love to have detail and section examples. Robert, which type of details and sections would you like to see? I think you might have my email address. Maybe you can email me and let me know. James MacArthur writes, do you have to check moisture content of CLT during construction? Yes, definitely. CLT is manufactured to 12% moisture content plus or minus 3 to be within the manufacturing standard range. But as you know, it rains here, it snows, the panels get wet. The panels can get wet. We're not worried about them getting wet. We are worried about building up floor assemblies or roof assemblies onto saturated panels when there is no way for water to escape through that assembly. So we want to either give that panel time to dry out, and then we're constantly checking to make sure that the moisture content is to under 16%. That's our typical kind of quality control or quality assurance measuring point, or else we build assemblies that have that are vapor permeable so that water can escape. But yeah, definitely. Mark asks, future session on WSEC. Oh, is that Washington State Energy Code? And more detailed information on code implications. Okay.
Yeah.
Got it.
Okay, if there are no more questions, I'm going to go ahead and wrap it up. Thank you, Sam and Erica. So appreciate your time, and we'll look forward to having you back in a month. Just a reminder, if you attended and you're an AIA member, I do log these credit hours today. So not that I won't do it later on, but it'd be great if you guys can get off this session and email me right away with your member number, and I'll get those logged. And we are recording this, and it will be available for any opportunity to view again on our YouTube channel. You can get to that through our new website, which is aia.org backslash Spokane. So with that, again, thanks again, and thanks to all the participants that joined us. Look for us next month, and have a great day. Thanks.
Absolutely.
Thanks,
Thanks
everyone.
everybody. See ya.
Bye-bye.